Okay, I have found a program that allows me to share my screen and do a little mini recording, very much like on eCollege, but this might be a little easier for many of you to access because I know it can be difficult to access the chat recordings in eCollege. So anyway, we're going to give this a shot. So it's basically going to be the same recording or lecture that I did for eCollege, but maybe this will be a little easier to follow. As you can see, here is a document that is under doc sharing, and this document has a box here with different metric prefixes, prefixes, and it's useful when you want to convert within the metric system. So if you want to convert grams to milligrams or microliters to milliliters, you can use this box to do it. And so what I thought I would do is I would go through this sheet with you and using this box, because many of you, most of you did pretty well on the metric conversions, and actually on the conversions between the household and metric system as well as within the household system. But anyway, it doesn't hurt to go over it again for those that might still be a little confused. Also, please contact me. I can talk to you on the phone if you like. If you're in Fort Myers, I can meet you at the Fort Myers campus to go over some of these as well. So I am available for that. I have talked through some of these problems with students in the past, so it's really no big deal. Okay, so back to this page here, converting within the metric system. Basically what we've done here is we have our basic unit of measurement is placed in a box. It's our basic unit. We're just going to give it the number 1. And our basic unit for weight is gram, our basic unit for volume is liter, and our basic unit for distance or length is meter. That is our basic unit. To the left of the basic unit are multiples of that unit. So 10 times the basic unit would be given the prefix deca. So if we were talking about if we're talking about weight, a decagram would be 10 times a gram. Okay, hecto means 100. Okay, so a hectogram would be 100 times a gram, which means there's 100 grams in 1 hectogram. Kilo, you all heard of kilograms? Kilo means 1,000. So kilo is 1,000 times a gram, or there are 1,000 grams in 1 kilogram. Now we can go the other way as well. We can go with fractions of the basic unit. And again, what's neat about the metric system is it's based on the system of 10. 10, 100,000, tenths, hundredths, thousandths. So it makes that really easy, and that's why we can use this box to help us with conversions. Okay, so let's just stick with weight here. A deci means a tenth, so a decigram would be 1/10 of a gram. Or stated another way, there are 10 decigrams in 1 gram. Centi means 100, so a centigram is 1/100 of a gram. Milligram, which is a very common weight or amount in pharmaceuticals, a milligram, as well as milliliter, is 1/1000th of a gram. So a milligram is 1/1000th of a gram. Milliliter is 1/1000th of a liter. And then we got a couple of placeholders, which I don't know I explained very well in my last recording, so I hope to remember to do that here. But we're down here to microgram. Micro is 1/1,000,000th of the basic unit. So a microgram is 1/1,000,000th of a gram. Or there are 1,000,000 micrograms in a gram. So basically, you probably would need this recording if you could, by just following the directions here. But sometimes it's easier to hear the directions read or discussed or elaborate a bit on. So I'm basically just kind of going to go through the problem that we have here. Let's see. The problem is we want to convert 5 grams to kilograms. So what I'm going to do is I'm just going to rewrite 5 grams equals X kilograms. You could do a little k or a big K. I've got a little k here. Let's do big K. Kilograms. X just means that's our unknown. That's what we're wanting to solve. So what we'll do is when you want it, again, grams and kilograms are all within the metric system. So what we want to do is we want to go up to our chart and we want to locate grams on the chart. We want to locate the number that's given to us. And it's right here. And I'm just going to highlight in yellow. And then we want to go to the box that contains the kilogram, the unit we're looking for. And that would be over here, right? I'm going to highlight it. So we're going from grams to kilograms. So all we're going to do is we're going to use these boxes to count. And these boxes really represent the number of places you're going to move your decimal. All right? So if we go from grams to kilograms, we're going to start counting 1, 2, 3. We're going to move our decimal places 3 places to the left because we moved from grams to kilogram. We move from right to left. So we're going to move it to the left. We don't count, as we're counting, we don't count the box we start on. We count the very next box. And then we count the box we end on. Okay, so we locate grams, because that's our problem, 5 grams, and we start counting with the next box, 1, 2, 3. All right, so what we want to do is, before you even, I probably skipped ahead a little bit, before you even do that, you want to go ahead and just rewrite your number, and I wrote 5 with a decimal point, and I put a bunch of zeros to the right of the decimal, and a bunch of zeros to the left of the decimal. And what I'm also going to do is I'm going to make this bigger so we can see it. So what did I say? We're going to move our decimal 3 places to the left. So that would, here's our decimal. We're going to go 1, 2, 3. I'm going to type in a new decimal. I'm going to quickly get rid of my other one before I get confused. I'm going to get rid of all unnecessary zeros. We need those. And we actually need the 0 to the left of the decimal. Yes, that is a correct answer, but if you have a dirty screen or if you print this out and you have little marks on your paper, you might not know if that's a decimal or not. So we're going to go ahead and put a 0 right there. And our answer is 0.005. And let's go back and put our unit in, kilograms. So 5 grams equals 0.005 kilograms. And that really makes sense, right? Because kilograms are greater than grams. So the kilogram is going to be a fraction of that. All right? Let's work a couple of these problems. Let's work, I'm going to leave some of these for you guys to practice on. Let's do number 5 here. Now I'm going to go back. I want to get rid of my highlights so we don't get confused. Get rid of that. And I'm going to get rid of that. So let's do this one. Let's see. We've got, let's move this up a little bit. 500 microliters equals X mils. So we want to locate the micro on our chart. So I'm going to scroll up, and that's where our micro is. And then we're converting to mils, so I want to go find our mils. I'm going to highlight that. Now before I start doing my counting, I kind of skipped ahead before. We want to rewrite this number, the 500. We're going to put a decimal, and we're going to put some zeros to the right and some zeros to the left. I know it looks kind of funny, but that's so we can do this problem. As you get good at these, you won't probably have to write those zeros, but it helps us keep track of where our decimal is. Alrighty. Now we've got our number rewritten. Let's go back up and let's see where, in what direction, and how many places we're going to move our decimal. We are going from mic to milli, micro to milli. So we're going from micro to milli. So we're going to go 1, 2, 3. Now these X boxes make sense, right? Once again, we're going to go 1, 2, 3. Again, we're going 3. We're going to move our decimal place 3 places to the left. So here's our decimal, 1, 2, 3. Let's put in our new decimal place. Let's quickly get rid of our old one before we screw up. and get rid of all unnecessary zeros. We do not need any of these zeros to the right of the decimal and to the right of the regular number. So I'm going to get rid of that. And I don't want a naked decimal, so I need to keep the 1 0, but I certainly don't need all these others. And that's our answer, 0.5. Let's add our units, 0.5 mils. 500 microliters equals 0.5 mils. Let's go, it's going to have us go the other direction. Maybe we'll go ahead and do number 1 here so we can do that. 1 kilo, let's do number 1. 1 kilogram equals how many grams? So what we're going to do is we're going to rewrite one. I'll make it bigger so you guys can see it. I'm going to go 1 point. Let's put some zeros to the right, and let's put some zeros to the left. I'm going to go ahead and get rid of. All right. So we've got kilograms and grams. Let's highlight them both. We've highlighted these before. Kilo and gram. Okay, so we're going from kilograms to grams. So we're actually, this time we're going from the left to right. So we're going to go 1, 2, 3. We went 3 boxes this time to the right. Remember, we don't count the box we start, but we do count the box we end. So 1, 2, 3. We're going to move our decimal 3 places to the right. 1, 2, 3. New decimal. Let's get rid of that old one. And let's get rid of unnecessary zeros. We certainly don't need those. And while this is the correct answer, we really don't want to leave our answer like that. If you're taking a chemistry class and you have to have so many significant figures, yeah, you might have to. But in medicine, we don't want to leave our number like that, because if somebody doesn't see that decimal, again, a dirty screen, or the copy quality is not very good on the paper you've printed out, they may not see that decimal, and instead of 1,000, they might think it's 10,000, which would not be good if we're dosing. So we're going to go ahead and get rid of it, 1,000. And I have to say, most of you were very good about not having extra zeros past the decimal, and not having naked decimals. That was very good. So that's our answer, 1,000. Let's put our unit back in there, grams. 1 kilogram equals 1,000 grams. Now the other thing I want to show you is how to convert within the metric system. I'm sorry, how to convert between the household system and the metric system, or within the household system. So I have an example here. This is actually under document sharing. Hopefully you guys have downloaded this and worked through it. But here it's a 2-page document where I have some sample problems. And then on the second page I have some conversions for volume and for weight. You can find various conversions like this and more in your book and on the internet. But here are just some that I went ahead and reproduced for you for purposes of working these problems. If there's a conversion you have to do and it's not on this list, hopefully I checked that, but if I didn't, you can find it so easily either in your book or on the internet. So let's go back. We'll be referring to the second page for each one of these problems. Alright, this first problem, 6 teaspoons equals how many mils? And whenever you instead of for our blank, we want to put a letter X. In algebra, whenever you're solving for an unknown, you usually use some kind of letter like X or Y. So 6 teaspoons equals X mils, and we want to solve for X. Now here I've got our conversion factor. 1 teaspoon equals 5 mils. How did I know that? It was right here. Basically, you look it up. So I type 1 teaspoon equals 5 mils. So far I haven't done any math. Our next step is basically to rewrite these problems. So to rewrite these numbers. So all you're going to do is you're going to take the 1 teaspoon equals 5 mils, and you're going to flip it so that it's written vertically. 1 teaspoon over 5 mils. You could have reversed it, flipped it the other way. You could have said 5 mils over 1 teaspoon, but I chose 1 teaspoon over 5 mils. Then you go to your problem, and all we're going to do is flip it, just like we flipped the conversion factor from horizontal to vertical. So 6 teaspoons equals X mils, 6 teaspoons over X mils. Then you're going to put an equal sign between them. Now, you could have flipped it either way, but what's important is that you're consistent. If you have teaspoons on the top over here, you need to have teaspoons on the top over here. And likewise, if you have mils on the bottom, over here, you need to have mils on the bottom here. So your numerator units need to be the same, and your denominator, the bottom unit of your fractions, need to be the same. Like I said, you could have flipped it just like I showed you here. So now what we're going to do is we're going to do some math. You're going to do something called cross multiplying, which means in this case that you are going to multiply the numerator on the left times the denominator on the right. So 1 times x, and you're going to write it over here, 1 times x, equals, and then you're going to multiply the denominator on the left by the numerator on the right, diagonally, 5 times 6. You're just going to write it 5 times 6. Now that we've set that up, now we're just going to do the math. 1 times x is x, and 5 times 6 is 30. And then you want to, of course, put in your unit mils. When you do the cross multiplying, I would not include the units because it gets really busy. When you're setting up the problem, when you're at this step, yes, include the units so that you make sure you got your numbers where they need to be. But when you actually do the cross multiplying, you notice I omitted the units because we already knew our units were good up here. But when you finally get your answer, do, of course, include the units. So let's try another one. Here's one, 5 grains, GR is not gram, it's grains, equals X milligrams. Our conversion factor is 65 milligrams equals 1 grain. Where did I get that? I looked it up here. Some places you'll see 1 grain equals 60 milligrams. I don't really care which one you use. I went ahead and used 65. And then what we're going to do, we're not going to do math yet, we're just going to set up our problem. And to set up our problem, we're going to set up from horizontal to vertical. So I'm going to take my conversion factor, and I'm going to go 65 milligrams all over 1 grain. And then I'm going to take my problem, X milligrams over 5 grains. Again, you could put grains on top if you want. I chose to put grains on the bottom. As long as the numerator is the same unit and the denominator is the same unit, we're good. 65 milligrams over 1 grain, X milligrams over 5 grains, and of course put an equal sign there. Now we're going to do the whole cross multiplying again. So it's diagonal. 65 times 5, 65 times 5 equals 1 times x. And then do the math. Pull out your calculator. 65 times 5 is 325. 1 times x is x. Okay. Now I'm going to do one more problem. And I'm going to skip down and do this one, where when you do your math, you are going to have one more step. And I'll show you what I mean. A lot of times you're going to convert somebody's weight in pounds to kilograms. In our country, in the United States, we don't weigh ourselves in kilograms. We weigh ourselves in pounds. But a lot of your dosing is in kilograms. So a dose might be 40 milligrams per 1 kilogram a day. Well, how do you figure out how much to give somebody? And we'll do that in some later problems during this term. But the first step you'll have to take to do those problems is you need to convert from pounds to kilogram. So what is our conversion? This is one you'll never have to look up because you'll probably use it a few times. But I have it right here. 2.2 pounds equals 1 kilogram. Okay, so I just rewrote it up here. 2.2 pounds equals 1 kilogram. So now we're just going to rewrite our conversion factor, and we're going to rewrite our problem from horizontal to vertical, just like we did in the previous problems. 2.2 pounds all over 1 kilogram, and then 150 pounds over x kilograms, and then put an equal sign. Our numerators check out. We got pounds on the top, and our denominators check out. We have kilograms on the bottom. Now we're going to cross multiply. 2.2 times x is 2.2x. Okay? 1 times 150. I wrote out 1 times 150. When you do the math, 2.2x equals 150, right? Because 1 times 150 is 150. But here's the thing. We don't have x equals 150. We have 2.2x equals 150. We haven't really solved for x yet. We need to isolate x. When we isolate x all by itself to the left of in this case, to the left of the equal sign, then we have our answer. But we really don't have our answer here. So how do we get rid of that 2.2, that coefficient? All you have to do is divide both sides of the equal sign by 2.2. And I hope you can kind of see it here. It's kind of hard to type this out. It's easier to write it on the board. There you go. So whatever you do on one side, you have to do on the other. So if I divide 2.2x by 2.2, I have to divide 150 by 2.2. The reason why I picked 2.2 is because 2.2 divided by 2.2 is 1, right? Or maybe if you remember from college math, those numbers are identical. They cancel out, however you want to look at it. But again, whatever you do on one side, you have to do on the other. But I chose 2.2, so it cancels out, so we get rid of that. So 2.2 divided by 2.2 is 1. That leaves x all by itself. Yeah, that's what we wanted. Now pull out your calculator and divide 150 by 2.2. And when you do, you'll get 68.2. And then of course don't forget your unit. Okay? Here's another sample problem here that you can do on your own, and you can do this mils to ounces on your own as well, although I've got it worked out. Again, if you have any questions, please don't hesitate to contact me. I'm going to take a look at some of the future calculation problems, and maybe do some sample lectures for you as well if you guys like, to kind of help you out. But I think they're fairly straightforward. And again, please contact me if you want to talk out any of the problems before you turn them in. That's absolutely fine.